is up, everybody? My name is Alex Carlson. Welcome to the AI Marketing Navigator. This is your daily compass in the ever-evolving world of AI marketing. Today, I just thought it would be a good idea to hop into a little bit of like artificial intelligence 101. There might be some people who are just being introduced to the world of AI or AI in marketing, and some of the terms that are going to get thrown around on this show very often may be unfamiliar to them. So I wanted to provide some definitions and give a little bit of an explanation of some of the terminology you're going to hear on this show for sure. The first one is a large language model, or an LLM. I'm sure you've heard of that. I guess maybe I'm not sure you've heard of that. That's why I'm doing this episode. But it's a type of AI that is able to achieve general purpose language generation, essentially meaning that it can recognize and generate text. And here's basically how it works at a pretty simple level. The LLM takes in a ton of text input from books, websites, other digital sources, and it's basically doing a training. It's training itself on all this text, this incredible amount of text that it's inputting. And during this training, it's learning the patterns in language that we use when we write or communicate as humans, like grammar and facts, and even how people can usually talk or communicate, like I said. Then it starts to and is capable of understanding context. So when you ask a question to a large language model or give it a prompt, like you may have done if you've used some of these generative AI tools that are based on some LLMs, the model uses what it has learned from all that input to understand the context of what you're asking for or what you need from it. If you ask it to tell you a story about a dragon and a knight, the model is going to know what a story is, it's going to know what a dragon is, and it's going to understand the context of why the two might be weaved together into a fun series of events, or disastrous, depending on whose point of view in the story, I guess. And then generating responses. So based on the context of that prompt that you ask it, the response would be like the story. So the model generates a response. It picks the words that make sense together contextually, how you would form a sentence when you talk, or the model that it's trying to emulate would form a sentence, and it tries to be coherent and relevant to what you asked it and what you asked of it. And then the LLM is characterized by adjusting and improving on the learning that it's doing. So sometimes it might make mistakes or give answers that are not perfect, and over time, with feedback, it will improve and learn. So we've already seen an incredible rate of release of newer versions of LLMs from OpenAI and Google and the like, and they're being trained on even more and more text with better techniques, and they're learning faster and faster and getting just that much more accurate. So LLM, large language model, that's the first term. Another one is artificial neural network, or ANN. And this is defined as a computational model inspired by the brain, the human brain, a biological neural network. And how the brain processes information, and consisting of interconnected nodes or neurons in the brain, and how those nodes work together to solve problems. So you can imagine your brain as a giant network of tiny neurons, as an interacting electrical based network of neurons or nodes, and those neurons are connected to each other and they're sending signals back and forth. That's how the human brain thinks and learns and remembers and computes and all of that. Now, an artificial neural network, an AAN, is basically a computer version of that. Instead of neurons, it's using little math equations, little ones and zeros to build out those nodes, or artificial neurons, and then those nodes are kind of connected in a variety of ways. There's like the input layer where this network is getting information. There's the hidden layers, kind of the middle layers, where it's taking the information from the input layer and it's trying to understand it. Each node in these layers is doing its little computation or performing its task that the math is telling it to, and it passes it along to the next layer and like an output layer, which is essentially where you get your answer. And after the output layer will probably decide that, this picture that you asked me to generate is 90% likely going to be a cat. And if it reaches a certain threshold like that, it's able to make a decision and produce an output. And then each connection between these nodes actually has a different weight or importance, which kind of tells the network how important the context is between those things. So when the network makes a mistake, like saying a dog is a cat or something, it can adjust the weights to get better, and that's how it makes the corrections, how things are related. um, Moving on, transformer model. So this is a type of neural network architecture that's designed to handle sequential data like text. And it uses what's called self-attention mechanisms, which we'll touch on here in a bit, to weigh that importance between the different words in a sentence. So you can imagine a book that is able to maybe understand and translate languages instantly. And this book uses a trick called a transformer model to do that job. It's a type of AI that's used for understanding and generating human language. It's, again, kind of broken down simply. It uses what are called attention mechanisms or self-attention mechanisms. And it's like having the ability to focus on the important words in an entirety of the sentence. So when you read a story, you're paying attention to the different parts to understand it. The transformer does the same thing, but in a much faster and more clever way. It looks at all the words, figures out which ones are the most important for understanding the meaning of the sentence. And it passes that information to layers like we've talked about. Each layer helps the model better understand. We talked about the input layer, the middle layers, and the output layer. And then it uses another technique called positional encoding. And this is like imagine a puzzle, and each piece has a specific spot. And so the transformer model uses this positional encoding to keep track of the order of the words. So it knows which words comes first, which word comes next, where it's actually placed sequentially in the timeline. And then more training, just like we learn as we practice, the transformer model learns by intaking lots and lots of text. It sees a lot of examples of sentences and learns patterns from them over time, and it gets much, much better and really good at understanding and generating that text. Okay, self-attention. We talked about that a bit when we talked about the transformer model of an ANN. A mechanism, this self-attention is defined as a mechanism within neural networks, particularly in those transformers, that allows the model to weigh the importance of different words in a sequence. This is how the model actually builds and adjusts understanding in the context of the language between the words. So imagine you're at like a big party and there's a ton of people that are talking really loud and really fast, and there's a bunch of conversations happening, but you're able to focus on the one you're interested in and the one that you need, even if you're getting a lot of noise and a lot of extra distraction. This kind of spotlight focus is similar to what a self-attention does, self-attention mechanism in a transformer model does. So step one, it's going to focus on the important words. So if you're reading a sentence like the cat sat on the mat, if you want to understand the sentence, you need to know that cat and mat are important. Self-attention helps the model figure out which words in the sentence are most important to actually understand the meaning. It's going to then make connections between those words. So self-attention looks at each word and checks how it relates to every other word in that sentence. For example, it would understand that cat is related to sat and mat. It's like making a web of connections between all the words to see how they are linked. Then it assigns an actual weighted score or an important score to the relations between those words. It gives a score to each connection, decides how important it is. The high score means a strong connection, like cat and sat. A low score means something weaker, like the and mat, maybe. These scores help the model to actually focus on the more important parts of the sentence. And then it's going to combine all the information, everything that the self-attention mechanism has learned from digesting that sentence, and it's going to combine all the important information to understand the overall meaning. And it's like putting together a puzzle where the most important pieces are kind of highlighted. Last thing I wanted to define quickly here today, so we don't run too long, is just a GPT. So chat GPT or custom GPTs, you've heard us talk about those terms and terminology before. It stands for Generative Pre-trained Transformer. So it's a transformer, which we also defined, and it's a type of transformer model that's been pre-trained on a large subset of certain and particular text data and is fine-tuned then to perform specific tasks and outputs. It's particularly known for being able to generate contextually relevant and coherent text. So hold a text input and output conversations, and that's what we're seeing from a lot of these GPT-based tools, like from OpenAI, ChatGPT, and other generative AI tools. So let's break down that term a little bit, generative pre-trained transformer. So imagine you're building a robot or something that you want it to be able to write stories and answer questions and have conversations. So something that AI would be very appropriate for. This robot is built using a special schematic, a special plan, and it's called a GPT, or a generative pre-trained transformer for short. So let's look at each part of that. Generative. This means that the robot is able to create things, like it's going to be able to generate sentences and stories and poems, and as we've seen, songs or images, and it can invent them from scratch. Pre-trained that means that before the robot can start helping you or performing its task, it needs to learn a ton about the language, a ton about its expertise or subset of data that it needs. So you're gonna train it, and it's gonna go through pre-training. So it's a pre-trained robot, let's say. And then a transformer, which we know about and we have defined, is that special design or architecture that's going to make that robot understand the context between words. It's going to build a neural network, and it's going to be able to learn and adjust that context. So that's where you get your GPT, your generative pre-trained transformer. Anyway, so that was a lot of information to throw down at you one day. Anyway, so I hope you found some value. If you enjoy the show or find it useful in any way, please do me a favor and subscribe or follow on Spotify, or by using the RSS feed to follow in the podcast app of your choice. And a review on top of that would be hugely appreciated. Until next time, thanks everybody for joining me, and remember to stay curious, stay consistent, and keep navigating forward. Bye.